Partitioning a line segment, both from the origin and not from the origin. In this video, you're going to get the definition of a directed line segment, my strategy for partitioning the segment, 2 examples, and then you'll summarize. So a directed line segment is a line that has direction. That means it has a start and an end. For our purposes, we're going to go from left to right. So that means the farthest left point is going to be our start, and the farthest right point will be the end. This will help make sure all of our ratios match, yours to mine and yours to everyone else's. So here's my strategy outlined. You're going to take the segment, you're going to plot the segment, you're going to draw in a right triangle so that segment is the hypotenuse, like we were doing the distance formula. Then you're going to partition the legs of the triangle, and you're going to use those partitions to find the partitions of the segment. So let's see an example. So I'm going to pause while I graph this, and you might want to sketch it out on your own, so you might want to pause as well. So here's my line segment AB, with B at the point 918. Now I'm going to draw in those lines to make the right triangle, and starting at the origin makes this part pretty easy. There's my 2 lines. So I know, just from the coordinates, that this segment down here is 9, and that this segment up here is 18. So if I'm looking at the ratio 4 to 5, the 9, that's easy. 4 plus 5 is 9. I have 9 units, so the partition is going to happen right here at 4 units in. So we have 4 to 5. For 18, that's just going to be twice as big, because 18 units is twice as big as 9. So I'm going to count up here. I have 2, 4, 6, 8. So that's 8, and then the rest of this would be 10. So that's the partition I want. I'm going to go back to my line tool here and draw straight from here over to here. And my graph is a little rough. 2, 4, 6, 8. Yeah, okay. So my graph's a little rough, but our point should happen right around here, and it should be at the point 48. And that's the point that partitions this segment into the ratio 4 to 5. Again, I'm going to pause while I draw out the example, but notice that my endpoint is not at the origin this time. A is at 510. So here's my line segment AB. I'm now going to construct that right triangle, so AB is the hypotenuse. So this one's going to go right over here. This point will drop down here. Then I'm going to look at the lengths of the lines that form. So this length here is 5. And this length here is 10. I can just count that, or I can kind of use the clues from the coordinates. These 2 coordinates are 5 units apart. These 2 coordinates are 10 units apart. So the ratio we're looking at here is 2 to 3. So that's a total of 5 parts. So that's good for the 5 unit side. So 2 to 3 breaks down right here. And for 10, again, that's going to be twice as long. I chose easy examples. So that'll be 4 and 6. So I'm going to use that line tool again to help me be as accurate as I can. Looks like this graph's a little bit better today. And there we go. There's my final point. So finding the point is not too difficult. If I want you to give me the coordinates, just be careful, make sure you're figuring out the coordinates all the way from the origin. So these coordinates here would be 7, 14, because I added 2, so I started off at 5, 10, I added 2 to this one, and I added 4 to this one, so 7, 14. So the point 714 partitions the segment into a ratio of 2 to 3. Don't forget to summarize. you should try to, as briefly as you can, maybe 1 to 2 sentences, see if you can summarize the strategy that I explained. If you have a different strategy, feel free to summarize that one, but this is the one that I will be using most often. And please, 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 if you have questions about ratios, make sure you ask so that you don't get buried and overwhelmed.